welcome everybody to our next panel. I am very excited to have these amazing speakers speak to you about deploying software solutions to scale climate innovation. So today we have three fantastic speakers. We have James Thomas from Desert Control. Desert Control is developing a liquid natural clay technology that improves soil's ability to retain water and nutrients, making it possible to cultivate crops in previously infertile areas. We have Michael Hedberg from Admaris, who's mass producing complete homes inside of smart factories. And then we have Aaron Devola from Siemens, head of sustainability. It is a pleasure to have you all here. My name is Michelle Brechtelsbauer, vice president of strategy with Newlab. So we're going to get started with a pretty simple question to the panel to let them all explain what they're building and what they're doing. So to each of you who are building novel solutions and supporting novel solutions to address the security of food and water, which are, of course, the foundations of human society, can you please briefly describe what you're building and how it's used to address challenges across these critical systems? So the problem you're solving, the use cases for your core impact, and of course, how it relates to climate.
Yes, so we have been developing a technology able to solve the biggest challenges in construction, specifically in the housing industry. Construction is one of the last industries that still needs manual labor. It's all based on skilled manual labor. And the problem is the world is running out of skilled manual labor. And it's causing the price of homes to increase very fast. There's a massive shortage of affordable homes in the world. And it's increasing all the time. It's a staggering number of 1.6 billion is the shortage of affordable homes. And we've been focusing on a technology solving that problem. So the technology we have developed allows us to mass produce homes in a factory, 100%. Without any need for skilled manual labor anymore. So no construction labor. All the skilled tasks have been given to robots. We have in the design 141 robots out on 26 different production lines that are doing all the difficult work. And we can now hire assembly line labor, which can be literally trained in a day to work in a factory because the task given to them is so simple. And since robots are very efficient in doing their job, we actually are reducing also the amount of labor by 95%. So we're now able to reduce labor amount by 95% and only need assembly line labor, which has drastically dropped the price, and we're eventually able to build homes at extremely affordable level, very high quality being produced in the factory, and also very sustainable play, because we are reducing a lot the CO2 emission and the waste, which construction is very famous on being extremely bad on.
Thank you.
Can you hear me? Sorry. So the vision statement, pitch line of our company is make Earth green again. But with the current administration in the White House, I don't say that as much. Or at least if I do, I'm wearing a green hat when I wear it. So I think you hit it perfectly in the sense is that our technology enables the retention of water, nutrients, and the potential for increased yield in sandy integrated soils. And so we allow agricultural companies to increase yield or reduce inputs. We can help to restore degraded land. The name of the company is Desert Control. I did not pick it, but that is the long-term hope, is that we will be able to bring back a lot of areas that are currently desert or desertification.
Thank you, James. Aaron?
So at Siemens, we truly believe if you can dream it, we can help you make it. And that's really our sweet spot. We use digital twin technology to really get very comprehensive, putting those details in. You just heard from Amazon talking about LCA capability and adding that to the digital twin so I can look and model very, very early in my dream phase what it's really going to look like in the make phase. And that's really where we feel like we can play a big role with startups, with scale-ups, and really help them take that into that manufacturing space. We can go from dreaming of one and making 1 million.
That's a perfect segue to start talking about commercialization, which is obviously kind of not the end state, but the most critical kind of path to cross when scaling these technologies. So to first our startups, and then, and Aaron, I'd love to hear how your digital twin technology is specifically helping. What are the biggest barriers that you're facing in terms of commercialization, and then how is Siemens helping to bridge that gap?
Sure. So our product is essentially made on site in a small factory. And so, and as I just articulated, the places we operate are not necessarily the most developed places in the world. And so we needed technology to allow us to scale this to work in very sophisticated environments and to work in very unsophisticated environments. And coming back to your comments about labor, with a relatively unsophisticated labor force. And so Siemens technology allows two things, one on each front. So we are able, from our technical base in Norway, to monitor the equipment in the field and to do all of those cool things that are now enabled by software and the internet. And so we can update software remotely to a machine anywhere in the world. We can monitor the performance of that machine anywhere in the world. And we make our product, which is essentially liquefied clay, using a tremendous amount of water, which has varying salinities and other chemical processes, and clay, which itself is not a standardized product. And so being able to feed the formula back to the machine remotely and to have the operator in a relatively unskilled way to be able to deliver this product in millions and millions of liters is really a huge thing. So we benefit on both sides. We don't have to have the skilled labor or as skilled labor, and we're able to monitor and control all around the globe.
Fantastic.
Yeah, so I guess talking about barriers, two that come to mind, mindset and scale. Trying to change this wonderful construction industry, which is extremely old-fashioned, traditional, underdeveloped. No innovation to really, well, name two in the last 100 years been precast and nail guns. So when we come and talk about automation, robotization, digital twins with Siemens and industrial AI, it's been taking a little bit of educating our clients and authorities. And scale is my favorite one because so many are trying to do this without scaling, and it's all about scaling for us. And scaling means a large facility, can't get around that. We're planning to mass produce homes. You need a big facility to mass produce homes. Second is we had to develop a very strong, robust supply chain to be able to support the mass production volumes. And then the last thing is it's a heavy upfront capex. You can't really get around that. So we thought we were going to spend 1 to 2 years to design the facility, but it's taken us now 7 years with a lot of help with software and technologies from Siemens.
You know, one of our barriers that we often fight with is that we work a lot with big companies with sophisticated systems and sophisticated IT structures. And the barrier for us has often been making that same level of technology, those same tools, much more accessible to more and more people. And that's one of the things that we've tried to do a lot recently. We've got now moving a lot of our on-prem type solutions, IT solutions, to as a service offering, so you can buy 1 or 2 licenses of our simulation software or of the design software or of the bill of material management software that you might need. And so we really want to be able to get more and more people access to these tools, and that's really been a barrier for us and one that we've been working pretty hard to overcome for these scale-ups to find us. Sometimes we're like a tanker ship, and a speedboat coming up alongside us isn't always very easy to dock with us, and that's something that we've been working with at Siemens. If you have some time, we have a booth up on the 2nd floor. We'd love to see you and talk to you a little bit about how we've got that. We've got a great startup program that we've launched recently that really helps people get low-cost access when you're in that startup phase to these great design tools we have. And we hope then we can grow with you. We hope then that we can develop and really create impact with you.
Yeah, I guess I would jump in there. My guys in the speedboat think they do a great job from their aircraft carrier. The access they've provided to my team in Norway has really been phenomenal. So highly encourage you to talk to them about it.
Amazing. Yes, please do. The booth that she's referencing is right at the top of the stairs, right over here. It'd be great to see you all there in a minute. But speaking of tanker ships and speedboats, I used to work at a startup in a highly regulated energy industry. And when we're talking about digital twins, we're talking about software, right? It's like a whole new world of enabling these companies to be able to present the actual impact their technologies would have to regulators without having to have built the whole thing yet. So I'd love to get your perspectives on both the headwinds, as I kind of referenced, but also the tailwinds that you're seeing when it comes to reducing and how regulatory barriers are, or let's not call them barriers, how regulations are impacting your business.
Well, there are definitely barriers. So, I mean, regulations, permits in construction industry have not been designed for industrial manufacturing, which is what we are introducing here now. So again, since we have automation, robotics, digital twins, industrial AI, producing in a high-tech factory, we would really like to get into type approvals like in every other industry. It's crazy getting every home permitted and so forth. And the fact is, if the regulations and permitting doesn't change, it doesn't matter if we mass produce homes if they can't keep up with that. So that just has to change.
I was going to say, maybe I could ask a follow-up question. I'm curious in the US if there are specific areas where you're finding headwinds or if how software in particular is supporting in addressing some of those changes that are needed.
Well, I would say we are discussing globally with authorities, and I have to say the mindset there is changing. They realize that something has to give, because if permitting becomes the bottleneck and we're able to finally scale and industrialize this, that has to change. And we're seeing very positive discussions towards type approval, but it's a complete ecosystem change that will be needed.
Yeah, I think from our standpoint, there isn't really a lot of regulatory headwind. You know, we're in the business of saving water, and nobody has too much. Well, some people have too much water, but we don't work with them. But everybody we work with has too little water, and so we haven't really had a problem there. And what we apply is 100% natural, and in the U.S. it's organic certified. So from a regulatory standpoint, yes, you have situations like when you're trying to do an application in Berkeley, California, and if anybody is here from Berkeley, there are permits for everything, what hours you're going to work, how much noise you're going to make, what you're going to do with the porta potty. So in that regard, right, we have some issues. But generally, we have a lot of tailwinds in the regulatory space all over the world, and we operate in the UAE and Saudi Arabia also, and they're, at least officially, the regulatory environment is on our side.
You know, one of the things that we see for a number of our customers is that, you know, they're really changing paradigms that, just like Mikhail was talking about here with Emeritus, are kind of looking at industries totally differently. And some of those first conversations with regulators, if they can bring this digital twin of the product to that and show them how it's different, show them how it's made, they've been able to really make some inroads, maybe not yet in substantial changes or there, but also with driving some sort of influence and helping them bridge their understanding. One of the things we find sometimes with regulators is they're not as knowledgeable, and if we can increase their knowledge base, if we can bring them up a level of understanding of what technology is available and what that technology is doing in the industries they're regulating, they're usually very interested to hearing from us, and sometimes having those digital tools to show them what we're talking about can be really impactful in those conversations.
Yeah, fantastic. I guess another key stakeholder group that we should talk about are those who really want to understand the impact that your technology solutions can provide, be that on economic development from maybe a city perspective, be that from your investors to ensure they have a return on their investment and they can actually see that scale. So I'd love to understand kind of like how impact is measured within your organizations. What are the key KPIs that actually matter to your partners? And then, of course, how does that impact your commercial go-to-market strategy? How does that impact how you engage with the investment community? So whoever would like to take that.
There's a lot of questions.
It's a lot of questions. We can split them up.
We've been, three metrics we've been following from day one is affordability, scale, and sustainability. And affordability, I have to say, is the most important one. If we're going to start affecting this housing crisis, the price has to come to a level where it's affordable. So if homes aren't affordable, nothing else matters. It's as simple as that. And our model has been built on meeting that massive shortage of a massive demand of affordable housing. And scale being the second, this cannot be solved without scaling. It's just simple as that. And it's industrial scale. we've been focusing on mass production, how to make that factory as efficient as possible. And we've not been looking at pop-up factories or micro factories or partially handmade solutions because they cannot deliver the economics of scale needed. So it's all about scale. And sustainability, of course, and technology is enabling it. And we have the benefit of coming from a terrible industry. I mean, construction, I've been 35 years in construction, so I'm allowed to say we're pretty bad. 37% of CO2 emission in the world is created by construction. We're able to reduce that by 75% or a little bit more because our whole factory will be powered by solar. And waste, construction uses about 40% of the world's resources, and we waste 40% of it. So we build actually in our factory up to 80% of the components from raw materials to size. So we are reducing waste by 80%. It's a bad industry, but with technology we can make real quantum leaps there. And positioning ourselves to commercialization, your question there, we're really looking at us being the factory for builders and developers, not their competition. We want to enable them to buy from our factory on time, on quality, a high quality product so that they can go after the massive shortage of housing. And yeah, I guess that's about the whole, the last question. You had three.
Fundraising.
Fundraising, the favorite one, yeah. So yeah, the investment community likes the fact that we are not a construction company, that we are not a speculative construction company, that we are also not competing with the builders and developers. It's more enabling them. So yeah, they see us more as, some say it can be a monstrous case because if we solve this, we actually can start going after that affordability of housing, and we're a very scalable advanced manufacturing play.
Killer. I love the stats on the CO2 emissions. It's actually incredibly impressive. Congrats for that.
A lot of F-150 pickup trucks idling on construction sites. But from a KPI standpoint, you know, we have three kind of buckets. One is input savings, right? Water, we have a lot of data, all of our use cases. We've been doing this for about 5 years. We're just now getting commercial. But water inputs, obviously, hugely important from a planetary standpoint. Frankly, to customers, a lot of time not that big a deal because they're getting their water for free. In the Middle East, there's clearly a cost to water, huge carbon cost to water because they're desaling everything. But for a lot of reasons, the governments don't bill the end users for the water. So just saving water in some sense is a good for the planet goal, but it's not an economic goal for them. But they are paying for their fertilizers, right? And so we measure our ability to reduce fertilizers. Most people are paying for their electricity to pump their water, and it can be a huge cost of water and obviously carbon emissions, depending on how deep your wells are and how much water you're pumping. All of our customers, other than our turf customers, because we're actually in the grass business too, are interested in yield. And yield matters to everybody because if you get more product, you use less input per product and you get higher revenues, so everybody loves yield. And those are kind of the areas we're most focused on. And again, we're working in some pretty remote environments. So we install a variety of sensors in all of these places, and that comes back to the software piece of this. All of that sensor data can come upload either to the US or Saudi operation or to the Norwegian headquarters, and can inform the irrigation and fertilizing and other decisions being made at the customer site. So we care about the same KPIs both for environmental and economic reasons as our customers do. And so I think that's really how we kind of measure ourselves. As far as investors go, you know, right now we're all about revenue growth, right? Everybody in this room, you never want to be about earnings, okay? Earnings are hard, they're variable, right? You just want a lot of revenue growth. And we're all about revenue growth right now. And that's what investors want to see, and they want to see us out there getting more and more installs across more and more crop types, et cetera. Because the opportunity, a little bit like the housing opportunity, you can put however many billions you want on the SAM, TAM, whatever that thing is. It doesn't matter. You know, it's all so huge that we're not focused on that. Sorry.
I mean, for us at Siemens, we know that over 90% of our portfolio has the ability to deliver sustainability impact among 3 big impact areas for us. So decarbonization, energy efficiency, resource efficiency and circularity, people centricity and society. And we sometimes are challenged about measuring that impact because we have such a multi-use portfolio. But what we try to do is a few things. One is really look at where we can find events like this to really amplify the climate tech going on, how we can work with the dirtier industries, if you would, and make them more sustainable through that by helping them model those sustainability impacts alongside of the other business outcomes they're looking for. And I will also say we have actually set some pretty ambitious goals, like we want to avoid in our customer emissions over 1 billion tons by 2030. So we really are setting those targets, measuring to those targets, and our investors at the Siemens level are also, I mean, if you think about a different investor type for sure, but they're also very interested in what we're doing around sustainability and the actions we're taking to support and drive a better place for all of us to live.
That's amazing. So I guess we'll transition to talk a little bit about partnerships, as I think that was also, I feel like you're giving me all the good segues, actually, so I very much appreciate that. But the question is, how do you leverage very unique partnerships, especially that exist between startups and organizations like Siemens and others, to advance your technology development pathways and also just accelerate that commercialization pathway as you're going to market? So that question is geared towards the 2 startups on the panel. And then Aaron, first for Siemens, how do you, I know you've been alluding to it throughout this panel, but can you be a little bit more specific about how you specifically collaborate with startups like these and others across their various stages of growth? And specifically kind of more into the sectors and the stages that you find yourselves gravitating towards? Maybe Aaron, you can start.
All right, I'll go first. So, I mean, for us, this is we're a very large, complex organization, and there's lots of different ways people wind up getting to us. I really can relate to what the woman from Amazon said, which is there's not one path to us, there's often many paths. But if we start at the beginning with this type of founder community and startup community, this is in the past been a little harder for us. We're trying to make it easier. We've launched a startup program that we talked about at the Consumer Electronics Show where we can offer significantly discounted software. We want to democratize access to the technology that we have. And then what happens there is we've got some people really starting and moving and maybe failing fast and starting over, but we believe by hearing their requirements, we can design better software tools that then can help move the whole vertical market forward in some sort of way. I'd say when we get to the maybe away from that startup to the scale-up phase, we do a little bit better job, I think, of working through verticals, working through industry organizations, finding partners who are looking to either find the right home to marry up with the right place. I was on a panel about a year ago with a company called Purim that does tire recycling, and they couldn't figure out who should buy their affluent. So they were able to take the tires and convert it to feedstock, but they couldn't find the right customer for it. And through our vertical market, we were able to say, hey, we actually do a lot in this tire space. Let us figure out and get you to the right chemical customer. And we can do a lot of that relationship or introduction or matchmaking maybe on that sort of space because we have such a diverse and broad customer base as we go into those vertical markets. So I'd say that maybe those are 2 ways that we do it. We do participate in a lot of industry organizations that help us find and do some of that matchmaking, but really it's about making the technology as accessible as possible and knowing what our sweet spot is really with helping you make not that first one, but maybe that 1 millionth one or that 100,000 in first one.
That's amazing.
Okay, so partnerships are critical, right? They're critical. I was a healthcare venture capitalist for 25 years before I started doing this, and partnerships are key, and great partnerships make everything easier, and bad partnerships obviously make everything harder. But on our standpoint, we have a variety of partnerships, including the Siemens partnership, which has been critical to allowing us to operate around the globe 24/7, et cetera, and to make mistakes virtually versus making mistakes physically, which is not such a good way to do. But we also have partnerships, academic partnerships. Obviously, we're in the agricultural space, so we have partnerships in the Middle East. We have partnerships with the University of Arizona, with the University of California. We are in the agricultural space, so we have partnerships with Syngenta and other of the large input people. And then on top of all that, we have a partnership with the World Food Program because obviously a lot of the soils we could affect are in places that are less developed. And we currently are working with them on a project in Iraq, for instance. And so, you know, we're all into it, and it affects every level of what we do.
Yes, for us too, the partnership has been absolutely critical. Actually, we could not have done what we've done without the partnership. So we had the product technology of how to build a house away from a construction site and put it in the factory, but we were lacking completely the production technology. We in construction, it's not in our DNA, automation, robotization, and industrial AI. So that came from our partners. Siemens and Porsche actually and EDAG have designed our factory. And it, on the software and the technology side, very early when we looked at homes being produced, a home was a project, so we had to change this mindset to make a home a product. And when we were supposed to design the product to a level that our partners could design a factory, we had to manufacture it, we realized very early, 2020 already, that the software in construction is not going to cut it. So we had to upgrade to a digital twin with Siemens, called Siemens NX Teamcenter, digital twin software, because in order to be able to mass produce it as a product in the factory, we actually have to design every single component in the home, down to the final bolt, glue dot, silicon line, so that our partners, Siemens, Porsche, and EDAG, could design the factory, where we have 26 different production lines and automated inventory, where everything goes and when, so that out eventually comes a finished product. And this is something I'm quite excited about, because not only do we have a digital twin of the product, but now Siemens and our partners have designed the whole factory in the virtual world. So we have a 3.3 million square feet factory with every equipment inside. It's a digital twin of the production now. And now comes the cool part. That factory has been started already in the virtual world. So we know it's going to work before we build it. And we have the takt time planned at 22.5 minutes per building unit. So if it's a small home, we can build a home every 22.5 minutes. The simulation that was done actually came out at 19 minutes and 20 seconds. So now having a digital twin of the home, a digital twin of the factory, the production, combined, I know it's getting technical, but in an industrial metaverse, we're actually able now to do things like, if you want to change a home design from having on one window wall 3 windows instead of 2 windows, within a fraction of a second, we know what it's going to cost. We also know if the factory will have a bottleneck that we can't produce enough windows and so forth. So it's bringing this wonderful construction technology, construction industry to a completely different level with the help of our partners.
It's like a video game.
It is a fun one.
It's like a factory video game.
Well, speaking of factories, I'd love to bring it back to Aaron and James to talk a little about the factory footprint of your organizations, which obviously are also core to your systems. So you could talk a little bit more about the software and the hardware systems that underpin the factory setting within each of your organizations. James?
So I guess quickly,
They're 2 different sizes. Mine fits on a kind of a large truck.
Yeah.
Yeah, we have a big product.
Very different scales.
So the factory we're planning to set up, it's a 3.3 million square foot factory with 141 robots out on 26 different production lines, feeding eventually the main assembly line, which pushes out the building unit every 22.5 minutes. And we produce 80% of the components in-house from raw materials, and 20% we buy just in time from global suppliers for products like sinks, toilets, faucets, sockets that doesn't make sense for us to produce. And this is all tied together by a very robust IT/OT architecture, connecting then design, production, and the supply chain into a very seamless process.
What does that look like on a smaller scale?
Right. So our current prototype is essentially 2 trailers pulled behind pickup trucks. And we're working on getting it all into one nice Class 6 truck with its own forklift. And I think we'll get there. But the hardware basically is how we handle the clay in the water, right? We have a proprietary method of breaking the clay into nano and micro particles and keeping it that way. And that's the secret, if you will, to what we do, and the rest of it is all pretty common industrial components. But controlling it all comes back to this question of, you know, can you make a recipe? Can you define a recipe? Can you program the recipe? Can you monitor that the recipe is being made the right way, in the right quantities, and delivered at the right rate? Inside our factory on wheels is the Siemens equipment, but all the operator sees is a tablet. Well, and a start button. And a lot of basic labor, right? I mean, you got to move the clay, and we're talking tons of clay and millions of gallons of water. So we're able to do the intellectual property piece of this, essentially behind closed doors. The electronic equipment and software is all behind closed doors. The actual reactors for making the product are all behind closed doors. And what the operator and the customer see is what happens outside. And we can monitor what's going on both semi-locally in our Arizona office if the machine's off-site, and in our Norwegian technical headquarters through the product. So. And also, I think importantly, some of the places we go don't have internet or a cell phone. And so when we do that, we have to do a little pre-programming before we deploy. But equally, that data is all captured and then returned to mothership.
What does that look like from the Siemens perspective? I'd love for you to weigh in on that.
I mean, for us, it's really about enabling all of this, right? By helping people make decisions, try things out, understand what changes, what the impacts of a change are going to be, whether it's 1 or 2 windows, whether it's doubling your capacity, whether it's changing out a machine or having a machine go down unexpectedly. How do I adjust and adapt? And that's what we really hope to be able to do with these digital twins, is have the flexibility to be more resilient. And that's really what I think drives our ability to do these things so much faster and with so much more ability to control and test and try. This iterative design process, this iterative learning happens so much faster when I can do it in the digital world before I take it to the real world. Or I can see what's happening in the real world and react to that much more quickly. So that's sort of that IT-OT integration, which we think is really pivotal to acceleration and scale.
Amazing. Well, we have a couple minutes that we'll fill in with some extra questions. So first, over to you, James. And actually, again, thank you for the segue between IT, OT. But I'd love for you to be able to talk a little bit more about how you're leveraging AI and edge compute to enable deployments of these factories kind of in the real world setting.
Wow. I'm the VC guy. I'm not the technology guy. But you know, I think I've covered most of it from some sense, is that we're very data driven, we're very data intensive, and we do try and make our mistakes either digitally or at least in our own backyard, because we do this very publicly, right? We show up and there are people watching us do this, and you do not want to have a problem at that point. It has happened, but you do not want to have a problem at that point. And so I think, you know, the extent that we can do the digital testing ahead of time, I think this idea of predictive maintenance a little bit, I mean, we grind up a lot of clay, right? It's not a simple, low-friction process. And so we do some predictive maintenance modeling on that whole process too. And the ability to be both real-time and then when we're off the grid, come back and have it seamlessly integrate is pretty important. And I will say something else, and I know that everybody here in this room is probably really a tech geek, and that's great and awesome. But if you have to recruit those people working, again, in our environment, you know, when you say, hey, we do ag tech, and we go really remote places when it's really hot, and we do all this really pumping of stuff, you do not get tech geeks to sign up for that job. But if you say, you know, we have digital twins, and we have global automation, and we work with one of the world's leading companies, then you get some high quality talent. So I don't know if that was on point, but it's something I think about and appreciate every day.
But I would just add one thing to what you said there, James. You talked about having this inability always to be connected. This is where edge compute can be really helpful. It does 2 things. One, it helps you make the decisions and do the calculation local to where you're executing your process. So you don't necessarily need to be sending the data back to a hub that's far away. I can take that data, I can make the decision, take that intelligence locally, especially when you have limited ability to be connected all the time. That those connections kind of come and go or come at different times. So.
Amazing. Well, I think with that, we will wrap it up. Thank you so much. As I said, please visit the Siemens booth upstairs and learn more about how all of this can support your company, hopefully, as well. Thank you.
Thank you.